Alright guys, this is going to be a fairly short lesson. This is about inverse functions. This is not in your book. The practice on this will be graded. You'll have 2 shots at it. So make sure you watch these videos carefully and let me know if you have any questions. So first of all, in order for the sine, the cosine, and the tangent to have inverses that are functions, you got to restrict the domain. Kind of like we did with the square root function, how it had to be greater than or equal to 0 because the square root is an inverse of the parabola. Well, we haven't graphed sine and cosine yet, which we're going to do next. But those kind of look like waves. So if you turn them to do the inverse, you do the horizontal line test, they don't pass. So we have to restrict the domain. So when we're talking about inverse functions, okay, then we're going to restrict the domain. So when you give an answer to an inverse function, the cosine, you're going to always give an answer, okay, the domain, we're restricting the domain. The domain is going to be between 0 and pi, or 0 and 180, whatever you want to look at it. Okay, so any answer you give when you're talking about inverse functions, and I'll show you that. For cosine, it has to be in between there, because remember, every cosine has infinite amount of answers. You can just keep going around the circle, and even on the unit circle, there's 2 different answers. So we're going to restrict, so when you restrict the domain from 0 to pi or 0 to 180, that's for cosine. All right, for sine, it's going to be a little bit different. Okay, and you'll see this when we actually start graphing these. But for sine, we're going to go from negative pi over 2 to pi over 2, or negative 90 to positive 90 degrees. Okay, and I guess technically we should be using brackets here. So think of these as brackets. Now see, I could have started this all over, but I'm not going to. So these are brackets because they're included. Okay, so whenever you are giving these, that's going to be your domain. Okay, and then for tangent, the domain is going to equal, and it's going to be from negative pi over 2 to pi over 2. Now, notice these have parentheses because the tangent of pi over 2, remember that on a circle, that would be 0, 1, so y over x, that would be undefined, so we're not going with that. Okay, or negative 90 degrees to 90 degrees. Okay, so whenever you give an answer that has to do with inverse, you have to stay in this realm. So cosine 0 to pi, because that'll give you all your, from negative 1 to 1, your values. This will give your values from negative 1 to 1. And when I say that, like the sine of negative pi over 2, that's negative 1. And then the sine of pi over 2 is 1. Same thing with degrees, all right? So let's say you had a problem that was, let's say, the cosine inverse of 1/2. All right, so we got your little negative 1 that represents the inverse. So what this is really asking you, okay, we've already done this in problems. That's where you use the inverse cosine button on your calculator or whatever. We don't want to use calculators. We want exact answers on these. Okay, so if I have cosine inverse of 1/2, what that is really saying is, what angle has a cosine of 1/2? That's what that is really saying. All right, that's all it's doing. So remember, for cosine, we're between 0 and pi. So if you've memorized those first quadrants and stuff yet, then you would have an idea. And I can't predict what you're doing or what you have or whatever, but if you look at your little chart, between what angle has a cosine of 1/2? So in our first quadrant, remember cosine is the x value. Cosine of 1/2 is pi over 3 or 60 degrees. Okay, so it'd be pi over 3 or 60 degrees. So the answer to that, cosine inverse of 1/2 equals pi over 3 or 60 degrees. See, and that's in that domain right there. And I forgot that little guy right there. Real messy French. Okay, let's try another one. Let's say sine inverse. And I'm going to try to give you, ones from that you should know from the first quadrant. So sine inverse. Let's see. Let's do 1/2 for this one. Okay. So again, what that is saying is, I'll write it one more time. What angle has a sine of 1/2? Now remember, that's in, if you from negative pi over 2 to pi over 2. Okay, so remember, everything's based off the first quadrant. So it is what it is. You just got to know a quadrant. So sine is your y coordinate, so that would be 1/2. If it would have been a negative 1/2, it would have been down in here in the fourth quadrant. So our answer is 1/2. Sorry, duh. Our answer for the angle is either 30 degrees or pi over 6. So that would equal either pi over 6 or 30 degrees. I'm going to take a quick pause because people keep sending me messages, which is what I want you to do. So I'll be back. Okay. Hopefully we're understanding this. Let's try another one. Let's change colors up here. How about the cosine inverse? Somebody give me a value. Radical 3 over 2. You haven't done any negatives, French. Okay, throw a negative in there then. Cosine inverse of negative radical 3 over 2. Okay, so again, it's asking me, I'm not going to write it, what angle has a cosine of negative radical 3 over 2? Now remember, we're limited between cosine from 0 to pi. It tells us that right there. All right, so the only place the cosine is negative is and from 0 to pi is in the second quadrant. So now, here's what we do. So I know I'm looking for what angle is, let's just go positive, cosine of radical 3 over 2. So I know that's pi over 3. Nope, wrong. Idiot. Cosine, I know it's 30 degrees or pi over 6, but that's positive. Now, it's going to be negative. Look on the back of this little guy. Negative, it was the pi over 6, so we got to go to the 6 here, and that is 5 pi over 6. I don't know if you can see it, but if you're looking at it on your own, that's negative radical 3 over 2. It's always going to have the same denominator. Okay, so that's my answer. All right, 5 pi over 6 or 150 degrees. So that's going to equal 5 pi over 6. And you don't have to give me both answers, but I'm just showing you how it can be both of those. Okay, that chart is a very, very helpful thing. All right, how about, let's say, tan inverse of, let's go, 1. Okay, so remember, tangent is y over x. Okay, so the only place y over x is going to be 1 is where x and y is the same. So we need to know where is the tangent, what angle has x and y the same? Well, 45 degrees. Okay, so that's going to be 45 degrees or pi over 4, because if you put radical 2 over 2 over radical 2 over 2, that equals 1. So that's where the tangent is 1, 45 or pi over 4. So that would be 45 degrees or pi over 4. Now if I just change that to a negative 1, okay, so again it's got to be a 4 denominator or whatever, but again if you just look, we're for sine, or for tangent, we're going from negative pi over 2 to pi over 2. So in order for it to be negative, it's got to be in the fourth quadrant, because that's where that is. So I know it's going to be something over 4. All right. So if I look on here, right there, that's where the x and y are opposites. So, but it's going to be radical 2 over 2, negative radical 2 over 2, which is going to give us negative 1, this over this. So that's 7 pi over 4, or 315 degrees. So 7 pi over 4, or 315 degrees. Now, see what I just did there? That's wrong. Then why'd you do it? Because I want to show you something. Remember, our domain for tangent is between negative 90 and 90, or negative pi over 2 and pi over 2. So those aren't in that domain. So guess what? Those are the right place, but the wrong answer. So what I have to do is, it's real simple. Well, if I'm pi over 4 to here, well, go back this way, that's going to be negative pi over 4. And think about it, 7 pi over 4 is pi over 4 away from being 2 pi. So even though that's the angle, that's not in my domain, so I would make it negative pi over 4, or negative 45 degrees. Okay? Got to be careful about that. It's got to be in that domain area. It's got to be in the domain area for cosine, sine, and tangent. Okay? Sine and tangent are negative pi over 2 to pi over 2. So your answer has to be in there for inverse angles. Has to be. And just to show you, just showing you here, like, so the sine, so let's say I have a sine inverse of negative radical 3 over 2. Okay? So I know that's going to be in my fourth quadrant. How do you know that, Mr. French? Well, it's got to be in the fourth or the first quadrant, because that's the domain. Again, I keep referring to that. Negative pi over 2 to pi over 2. Negative pi over 2 is at the end of the, so to speak, going backwards, the fourth quadrant. Pi over 2 is at the top. So that's what I'm looking at. So if I get a negative on either tangent or sine, negative in here, I know I'm in the fourth quadrant, and I'm just going backwards. So if I remember, or I look, or whatever, that I know the angle in the first quadrant that has a radical 3 over 2 is my sine, that is 60 degrees, or pi over 3. So this is just going to be negative 60 degrees, or negative pi over 3. And again, if you look right here, radical 3 over 2, whoops, you can't see that, dummy. Radical 3 over 2, see, that's the sine, but it was negative, so it's going to be this negative angle. That's what I did. Okay? All right. One more quick one, and then that will be it. All right, so last one here. So let's say I have, I'm going to get you on this one. Let's say I have the sine of the inverse tangent of 5/6. Okay, now that's not one we know. Like, there's no 5 over 6 tangent on the unit circle. So what I want to do is I want to draw the figure. Okay, so all we're going to worry about is this right here, right now, because it says what angle has a tangent of 5 over 6. So if I just draw me a little triangle, doesn't matter, just make sure it's a right triangle. Okay, put your angle wherever you want. I'm going to put my angle down here. I'm going to use alpha. Okay, so if it says I want to know what this angle is, it has a tangent of 5 over 6. So tangent, remember, is opposite over adjacent. Okay, so that angle has a tangent of 5 over 6. All right, I can use Pythagorean theorem to find this. So that would be what? 25 plus 36 square root of 61. Okay. So then what I want to know is, so what is the sine of this angle? Now that angle is right here. That's what that is represented by. Okay, because that angle has a tangent of opposite over adjacent 5 over 6. See right there? So really all I want to know is the sine of alpha. So sine, remember, is opposite over hypotenuse. Rationalize that. 5 radical 61 over 61. And that is that. Can you do one more of those? I'm a little confused on that one. Sure. What do you want to do? Let's say I want to do the tangent of the cosine inverse of, somebody give me a number. I don't care. Give me a number. No one? Seriously? I got to come up with my own? It's just like first period. Nobody's talking. Okay, so let's say it doesn't even matter. How about we do 5/7? Let's do that. Okay, so again, let's call whatever that's going to be alpha. So I'm going to draw my triangle. Make this alpha. Cosine is adjacent over hypotenuse. See? So that's what that is. That gives me that drawing. So I need to find my missing side. So that's going to be, all right, since I have C, it's going to be what? The square root of 7 squared minus 5 squared, which is the square root of 49 minus 25. Brain, brain, brain. 49 minus 25, which is 24. Okay, which if I simplify that, that's 4 and 6, so that's 2 radical 6. So that's 2 radical 6. Move it up, move it up, move it up. Come on, man. Okay, so the tangent of alpha is opposite over adjacent. Boom. Okay, your practice on this, it's in the assignment, if you look at that, on eCampus. Okay, and it is graded. Okay, it's like a mini quiz. Okay, till next time, people. Have a good one. Bye-bye.